Alright, same idea as before, but with a very important difference. Same jogger, 2 meters tall, running down the street at the same rate of 2.5 meters per second. He is approaching a 3-meter tall lamp on the other side of the street, and that makes a massive difference. The street itself, now we need to know how tall it is, how wide it is. It's 5 meters across, and this time he's not going to be 10 meters away from the lamp, but rather 10 meters away from being directly across it. So our diagram is different. Now our lamp is sitting over here, and our jogger is running over here. And so the shadow comes down across the street, and we don't really care about this distance so much, but the shadow itself will appear right over here. So this is a little bit tougher. It's going to take a bit more work for us to figure out what is going on. What happens is that there's some stuff that happens horizontally, some stuff that happens vertically. It's probably best for us to take those two things separate, one from the other. So the bit that happens horizontally is across the street to the runner, and we have this triangle over here. So that triangle, 5 meters across over here, and this distance, I want to be able to talk about it. I'll call this distance x, because I know that the runner is going this way, so I know dx by dt is this value. So this right here is x, and dx by dt is negative 2.5, or probably better, negative 5/2. So this right here is root 25 plus x squared, just by Pythagoras. The other part, pardon me, is the vertical component of the question. The vertical component is the lamp going up here, the light shining down to create the shadow, this distance plus the shadow itself. So that is all something that you need to imagine is sticking up out of the paper. And so for us to figure this out, we're going to have this very long triangle, something over here. This is 2 meters, this is 3 meters. This distance I know is the square root of 25 plus x squared. I need to define my shadow, so this is y over here. I should have a line about exactly how they're defined. I should say let x be equal to distance from the runner or the jogger to the point directly across from the lamp. And I should say y is equal to the length of the shadow. So I want to find dy by dt when x is equal to 10. And over here I have right angle triangles again, and similar triangles at that. So I know that I have y is to 2 what the square root of 25 plus x squared is to 3. Sorry, not just that, but 25 plus x squared plus another y is to 3. And so I can simplify a little bit, and I get y is equal to 2 times the square root of 25 plus x squared. Take derivatives of both sides with respect to t, and I have dy by dt is equal to, should do this using the chain rule, so it's 2 times the derivative of a square root is 1 over a half times the square root of 25 plus x squared times the derivative of 25 plus x squared is equal to 2x times dx by dt. This is not a single step. I'm just running out of room. Do this by justifying it using the Leibniz notation and then demonstrate what this is equal to. I can cancel these guys out and I can say that at x is equal to 10, dy by dt is equal to 2 times x over the square root of 25 plus x squared times dx by dt. These guys at least cancel out. The square root of 125 is 5 root 5, so I get negative 50 over 5 root 5, which will simplify at least a little bit. This goes in here 10 times, multiply top and bottom by root 5, and you get negative 2 root 5. Therefore, the shadow is contracting at 2 root 5 meters per second. It's a touch unusual that the y ends up alone over here. It happens with some of the equations. A lot of the others, you need to use implicit differentiation in order to keep going. So it's not just the chain rule, it's the chain rule applied to things that are occasionally quite ugly, on top of the fact that your diagrams tend to be rather difficult. So these are not easy questions. The fact that we only have a single lecture video should tell you that this is actually something where the examples take a tremendous amount of work. So do as many exercises as you can, work at them night and day, make sure that you are comfortable with this, because the next assignment after this week is going to have a number of related rates questions.